Hi guys, welcome to this video looking at what dynamic equilibrium is. If we start off with the definition for equilibrium then, it is nice and simply that the forward reaction and the backward reaction are both occurring at the same rate. So if we have a look at the example with hydrogen reacting with nitrogen to make ammonia, so 3H2 plus N2 goes to 2NH3, you know it's reversible because we've got this symbol here, which tells us that both reactions are occurring. So at any one point in a reaction, let's say with hydrogen and nitrogen reacting together, I've got 600 decimeters cubed. 500 decimeters cubed of that is hydrogen and nitrogen, and 100 decimeters cubed of that is NH3, ammonia. If the concentrations of both the hydrogen and nitrogen stay the same, so I'm not getting any extra hydrogen or nitrogen produced, I'm not getting any extra ammonia produced, that is what we call dynamic equilibrium. So it's not just saying that both the forward and backwards reactions are occurring at the same rate and at the same time, it's also saying that the concentration has stayed the same as well, whilst also remembering that dynamic equilibrium and any equilibrium must be in a closed system. Now what that doesn't mean is you've got exactly the same amount of reactants and products, so I don't have it 50-50 down the middle. Again, if we have a look at the example of hydrogen and nitrogen reacting together to make ammonia, I can have my equilibrium lying to the right, and if that's the case I might have 75% of my products and only 25% of my reactants. But if it's at equilibrium, I will stay at 75% of products and 25% of reactants. And similarly, if the equilibrium lies to the left, I might have 75% of my reactants and 25% of my products. If it's at dynamic equilibrium, it will stay at that 75% and 25%. In other words, the concentration, the percentage, will not change. Okay, we've got a couple of questions then to see how much you've picked up. First one being, nice and simply explain what dynamic equilibrium is. 3 marks for that. Number 2, in the heart of a process, nitrogen and hydrogen are reacted together to form ammonia. Part A, write the balanced equation for this reversible reaction. Hint, reversible reaction, think of the symbol you need to put in. And then B, explain what will happen to the concentration of reactants and products until it reaches dynamic equilibrium. So here, think you've just started reacting nitrogen and hydrogen together. What's going to happen to their concentration? What's going to happen to the concentration of ammonia? And then when it reaches dynamic equilibrium, what will happen to the concentrations of both? Pause the video, have a go, we'll see how you've done in a minute. Okay, let's see how you've done. So the first question then, which is explain what dynamic equilibrium is. Nice and simply, the first bit you need to say is the forward and backwards reactions are occurring at the same time. You can also add in there that it's at the same rate, that'll get you 2 marks. And then finally, you want to talk about the concentrations and say that the concentration or amount of reactants and products will stay the same. Question 2, write the balanced equation. So it's given you that nitrogen is N2, hydrogen is H2 and ammonia is NH3. So I can put those in there. 1 mark for that. The second mark is for the reversible reaction symbol, so putting that in. And then balancing it, so I've got 2 NH3. I need to double that because I've got 2 nitrogens on the left hand side. Therefore that gives me 2 times 3, which is 6 hydrogens, so I need to put a 3 in here, which gives me my balanced equation. So 1 mark for N2 plus H2 goes to NH3, 1 mark for the reversible reaction sign, and 1 mark for your correct balancing. And then part B, explain what will happen to the concentration of reactants and products until it reaches dynamic equilibrium. So you're starting off with only N2 and H2 reacting together, so the concentration of that will be high and it will go down, it will decrease as the ammonia is produced. Therefore, the ammonia concentration will go up, and then it'll get to dynamic equilibrium. And at that point, the concentration will stay the same. That's this video pretty much over. I have got a review question for you, which is, in the above reaction, dynamic equilibrium is reached. In the solution, there is 40% of the reactants and 60% of the products. Explain what will happen to the percentage of each after half an hour if the reaction stays at dynamic equilibrium. So think what we've talked about, what happens to the concentration at dynamic equilibrium. So what will happen to this after half an hour if it stays at that. That brings this video to an end. Hi guys, I hope you enjoyed the video. If you did, please click on like down below. You can also subscribe to get more updates. You can visit the website for more information and you can look at my latest video. Thanks for watching.